In this part, continuing from the previous section, we focus more on the tank's movement and fix the issues caused by using the translate method, such as not using physics for collisions with environmental objects. And we can easily achieve this by properly using the rigid body component on the player object. Next, we address the issue of the tank not properly interacting with the terrain and ignoring ground slopes, making the tank's movement much more natural. To fix this issue, we first calculate the ground slope using the method that will be explained next, and then take the necessary steps to resolve the problem. As you may remember, a little while ago the tank could easily pass through these boxes and had no real interaction with the environment, just like you can see here. In this section, we first want to fix this issue. So stop the game, select player blue, and add the rigid body component to it. In the constraint section, check X, Y, and Z under freeze rotation. We don't want the rigid body to rotate at all. Next, add the box collider component to tank free blue. Adjust the box collider to properly fit the player model. Now, if we run the game again, you'll see that the previous issues are gone and the tank properly interacts with the environment. So here we were able to use the translate method for movement while also having a rigid body for interaction. We pause the game. Next, we want to have all the objects here inside another object and manage the scene better. So we create an empty object and rename it to test environment. We put all the environment objects inside it. Then we temporarily disable the object. Now, we want to add a new feature to the tank. So we go to the My Trains folder and add train level 1 to the scene. Here, we plan to give the player the ability to detect terrain slopes. We reset player blue and do the same for the terrain. We temporarily disable local canvas so we can move the player more easily. We place the player here. Let's also reset the main camera so we can move the player more precisely. Before we continue, we run the game once, so we click on play. Look guys, this player can easily move on the ground and interact with the environment objects. But when it comes to moving on sloped surfaces, it faces issues and doesn't perform well, like in this situation. Also, it doesn't have the ability to detect the slope of the terrain to adjust itself accordingly. Next, we're going to work on these issues and fix them. So we stop the game and open the player controller script. Here we use the header attribute to create a new section called terrain slopes for private and public fields or variables that are being used. The first field we define is of type layer mask with the same title, and it's used for the raycast. The next one is ray point, which serves as the origin for the raycast. Next, we have ray distance, which holds the length of the raycast being sent, and by default we set it to 4. We also have the variables delay time ray and current time ray. Using this, we want to define a separate timer as well. Next, we want to define a struct called raycast_info and add the necessary fields. Fields like quaternion of type quaternion and heat normal of type vector. We also define a method called detect ground specs that returns this structure. Inside this method, we want to define an independent timer. This way, the operations in detect ground specs will be called at specific intervals and won't run frame by frame, which could reduce the game's performance. In this line, we use the raycast method to send the ray from the ray point and towards the ground within a specified stance to gather information about the terrain. We then return the gathered information. So here, we define two more variables of type raycast info. For the first variable, we name it raycast info temp, and for the second one, we name it raycast info. Next, we set the quaternion field of the raycast info temp variable equal to the slope obtained from the from to rotation method of the quaternion class. This method uses the up vector in world space and the hit.normal property from the train, which is perpendicular to the surface, to calculate the train slope. And we also set the hit normal field of raycast info to equal hit.normal. Next, we set current time rate to 0 so that this operation will repeat again with the delay specified by delay time rate. Finally, we return raycast info temp. In the update, we call this method and store the result in the raycast info variable. So we can use this variable later in different parts of the code. One of the most important places where raycast info is used is in the tank move method. In this method, we multiply the rotation, which is stored in the quaternion variable, by transform that forward in this line, so that the train slope is taken into account. I think the name of quaternion was misspelled. Let's fix that. We'll bring these two variables up and place them here as well. So, with this method, we can easily get the train slope and use it in the move method like this, allowing for a smoother movement for any type of player on any train. We save the script and return to Unity. Now, we need to assign the ray point field. So we create an empty object for ray point under player blue and set its height to 0.5. For the layer mask field, we select the ground layer that was assigned in the train. Of course, the ground layer hasn't been defined for the train yet, so we need to add it. We click on Add Layer and then add this layer. Now we select the train and assign this layer to it. We return to player blue and assign values to the fields. We run the game one more time. You can see that the player moves smoothly on slopes now, and no longer has any issues with detecting the train slope. Another feature we want to give the tank is the ability for the tank itself to align with the train slope, so its movement looks more natural. So we stop the game and continue with the work and returning to the script. Under the tank turn method, we define a new method called tank pitch. Inside this method, we define the variable tank rotation and set it equal to the lock rotation method. In the parameter for this function, we use the part of the code we wrote for tank move, which helps us achieve a new rotation around the x-axis for the tank. Next, we define a new field called tank for the body of the tank. Here, we set the rotation property of this field equal to the lerp method from Quaternion. For the first parameter, we use tank.rotation, and for the second parameter, we use the tank rotation variable. The third parameter requires a value between 0 and 1. According to the definition of lerp, the closer this value is to 0, the more it will move towards A, and the closer it is to 1, the more it will move towards B. So we choose 0.2. Now we need to call this method in the update and assign the tank field in the inspector. So we return to Unity, select player blue and assign the tank field. We enable the local canvas object again and run the game once more. As you can see, not only is the train slope detected for smooth tank movement, but the tank's body also aligns with that slope. And this is exactly what we wanted to achieve in this section. We stop the game and save the project. We select the player, click on the override button, and then choose Apply All to apply the changes to the prefab as well. Alright, let's test the game on mobile as well. So we select player blue, check the is mobile field, and then run the game. The camera movement is a bit too fast in this case, and it would be better if it was slower. So, we stop the game and go to the inputs controller script. In the methods related to mouse input, before using mobile.touch for X and Y, we multiply by 0.25 to make the movement slower. We save the script, return to Unity, and run the game again. As you can see, everything is working correctly. In this section, we were able to add features like interaction with environment objects and train slope detection, both for the tank and its body. We also tested the game on both mobile and PC. We uncheck the is mobile option for the player and overwrite the prefab again. We go to the resources folder and add the necessary script and objects for the green and red players. Then we apply the required settings. We double-click on player red and open it in the prefab editor. Then we do all the same steps we did for the previous two players and for this one as well.